Hey guys, today I'm going to talk to you about how to do division when decimals are involved. So we're going to split it actually into two lessons. This one's going to be dividing by a whole number, a decimal by a whole number, and in the lesson we'll do tomorrow, it'll be dividing decimals by decimals. So this is lesson 3-7, and again, divide decimals by whole numbers. And the date is going to be 9/19/18. Okay, so as we talked about yesterday, problems are presented to us either horizontally or vertically, but then we turn them around and use the decimal house. So I'm going to kind of keep a tally of what we're going to do in words on one side and then an example on the other. So let's say we start with this problem, 6.8 divided by 2. So we're going to do a really super simple example. Okay, so first thing we're going to do is rewrite the problem using the division house. And the division house, remember, is that kind of L fallen on its side. So it looks like that. And then we're going to place our two numbers in. So 6.8 is being divided by 2. So the order we saw them horizontally gets reversed when we put them under the house. And remember, the 6.8 is called the dividend. The 2 is called the divisor. The answer will be called the quotient. Now, I'm going to tell you right here, there's something you can never, ever do. Okay? And what you can never do is you cannot divide by a decimal. Now, today, that's not going to show up in your homework, okay? But we need to keep this idea here that we constantly need to look at the divisor. And if it has a decimal in it, we're going to have to do something to make the decimal go away, okay? Now, in our case, we're really lucky because there is no decimal. In the divisors for this lesson. Okay, so we're going to baby step you in there. Yay, right? So when that happens, what we're going to do, so we just got this kind of waterfall effect, is we're going to bring the decimal from the dividend into the quotient. So you know how when we were multiplying with decimals, we kind of temporarily pretended we didn't have the decimals there? Well, we're going to do kind of the same thing with division, as long as we first have brought the decimal point straight up into the quotient. So back to our issue over here. Here is our division house. We've got the divisor 2, the dividend of 6.8, and we're going to bring that decimal point straight up into the quotient. Okay? All right. At that point, we get to finally divide. So that's precisely what we're going to do. Divide. So for our problem, we've got our division house. We've got our divisor 2 and our dividend 6.8. We brought our decimal point straight up because our divisor is a whole number, and then we just divide. So 2 goes into 6 evenly 3 times. 2 times 3 is 6. Subtract, there's a difference of 0. Since 2 is greater than 0, I am going to bring down and continue dividing. 2 goes into 8 4 times exactly. And 2 times 4 is 8. And so what we call this decimal of 3.4 is he's called a terminating decimal. Terminating decimal. That means it terminated or ended. There was no remainder. No remainder. Okay. So the next question comes, what if there is a remainder? What if there is a remainder? So what we're going to do is that favorite word we learned before. We're going to annex a 0 one at a time. Continue to divide until the quotient terminates. So finally get to a point where there's no remainder or repeats. The same number just keeps happening over and over and over and over again. Okay? All right. I don't think you're going to see too much of the repeating going on in this homework assignment. But definitely we will practice that. Okay, speaking of practice, let's go and do a couple problems. So the directions are just going to say divide. Okay, so first problem, we're going to have 3.94, and we want to divide it by 4. So again, we're going to rewrite it with the division house. 4 is the divisor. 3.94 is the dividend. Now, my divisor does not have a decimal. That allows me to bring the decimal point straight up into the answer. So let's see where I can divide. Can 4 go into 3? And the answer is no. So I'm going to put a 0 in my quotient above the ones column. So then I'm going to see, can 4 go into 39? And the answer is yes. 4 goes into 39 9 times, which is 36. So I subtract and I get a difference of 3. As long as the difference is smaller than the divisor, I'm good. So then I bring down the next digit. And let's see, can 4 go into 34? Yes, it can go in 8 times, which is 32. And when I subtract, I get a difference of 2. Now, at this point, I don't have any more digits to bring down, but I'm not done dividing. So this is where I annex a 0, bring it down, and then I continue dividing. So let's see, 4 goes into 20. Oh, funny, I wrote my problem wrong. That's okay. Goes in exactly 5 times. So after annexing 1 0, I ended up getting a terminating decimal. So the answer is 985 thousandths. Okay? All right, let's try another one. 55.08 divided by 17. So now let's divide by a 2-digit number. So we'll set up the problem. Now remember, we can always estimate as we're going through this to see what kind of answer we might end up getting. I I talked about in the last video about compatible numbers. What's a number that the divisor can go evenly into that's close to the dividend number? So those are always options to try. See, there is no decimal in 17, so the decimal comes straight up into the quotient. And then I begin dividing. Let's see, can 17 go into 5? No, but it can go into 55. How many times? 3 times. That's going to give me 51. So I subtract, I get a difference of 4. So I bring down the next digit, which is a 0. And how many times can 17 go into 40? Well, 3 times was 51, so too much. So 2 times is 34. That will work. So we get 34, and we subtract, and we get 6 as the remainder. But we've got another digit, so let's go ahead and bring him down. Got an 8. So how many times does 17 go into 68? Let's see, well, it's got to be more than 3. If I did 4, I'm not sure, so I'm going to test it off to the side. And that gives me, let's see, 28. Hey, that's exactly what I need. So it terminated, and I got that when I divide 55.08 by 17, I get 3 24/100ths. All right, that wasn't so bad. So again, if I can't do the math in my head, I'm going to do it off to the side of the paper. And I don't erase my work because I never know if somewhere down the line I may need that answer again. All right, I'm going to go to the next page. And I'm going to pause, and I'm going to write down a word problem. And then I would encourage you to do the same thing once you see it pop up, pause it, copy it down, and then we'll solve one word problem together. Okay. So Kirsten and her 2 friends are sharing the cost of a funnel cake. The funnel cake cost $5.49. If Kirsten has $2, how much will she have left after she pays her share? So basically in this problem, we need to figure out how much it's going to cost each person to pitch in for the funnel cake. That's the first thing we're going to have to figure out. And then we're going to have to figure out if Kirsten has $2, how much will she have left over after she pays her share? So let's start with step 1. What is the share cost? So how much is it going to cost each person to share this dessert? Okay. Well, let's see what we know. We know we have 3 people because we have Kirsten and her 2 friends, and together they're going to pay that $5.49. So if I take that $5.49 and I divide it by the number of people, which was 3, that's going to tell me what the share cost is. So now, keep in mind, this problem is about money, so even if the division went past the hundredths place, money does not go past the hundredths place, so we may have to do some rounding. Okay, so let's start by bringing up our decimal point. And let's see, does 3 go into 5? Yep, it does. It goes in 1 time. And we get 3, and we have a difference of 2. So already I can tell Kirsten's getting some money back because it's going to be less than $2 for each person. Okay, so since 3 is greater than 2, well, let's go ahead and bring down the next digit, 4. And let's see, can 3 go into 24? Yeah, actually it can, exactly 8 times. So at this point we have 0, but we're not done dividing because there is another digit, the 9. And 3 goes into 9 3 times, which is 9. So look at that. It worked out perfectly. So keep that in mind. So the fair share, what each person's going to pay, would be $1.83. Each person pays. Where did that come from? Each person pays $1.83. Okay? That's just that piece. Ooh, that was a terrible box. That's that piece. And then that piece leads to the second question. The money Kirsten has left over. And that's your mondo big question we're trying to answer. Okay? So, what we know is Kirsten had $2. And we're going to subtract from that her share of $1.83. So let's go ahead and rename as we need to. So 1 whole is going to become 10 tenths. 1/10 is going to become 10 hundredths. All right, so notice that I lined up my decimal points because this was an adding problem or a subtracting problem. And now when I subtract, 10 take away 3 is 7. 9 take away 8 is 1. 1 take away 1 is 0. So, for our final answer, we have Kirsten will have 17 cents left over after paying her share, paying for her share of the funnel cake. Okay, I hope this was easy to understand, and we'll talk about it tomorrow. Thank you, guys.